So in this video I'm going to show you the executable MBSE profile again, and then I'm going to do something a bit different with this, which is to explain what are the workflows you can do with this profile without using activity diagrams, sequence or state charts. In other words, doing an entire project with just two diagrams. And the intent of that methodology is to simplify SysML. So if you understand how to do block definition diagrams, internal block diagrams for structure, then you would understand how to do it for behavior, and then you can take those two decompositional trees and dovetail them together. This is an approach around function block modeling. So I'll do the insulin pump system again, and I'm going to use the ExecutableMBSE profile. This is the 4.3e version. If you look on my ExecutableMBSE website here, then you can see that there is a link to be able to get this profile from GitHub. Now, conventionally, you might start a project with use cases, and use cases you might decompose with, say, an activity model. An alternative to that is to start with blocks and do a decomposition using the block model. So the first thing I'm going to say is let's define a system architecture structure using a block definition diagram, and this is for an insulin pump system. And the insulin pump system has an insulin pump, a continuous glucose sensor, and a blood glucose meter. So this is something called a block definition diagram in SysML, and it's derived from the class diagram in UML, allows me to do directed decomposition to be able to create part relationships between these elements. So my insulin pump system now has three part properties typed by these subsystems. Well, if I did the same within the behavioural domain, then I could do it with something very similar, and this profile adds the concept of a feature, which might be to deliver basal insulin, say. And this, rather than being a structural block, it's a functional block. So I'd say, well, to deliver basal insulin, I need to measure glucose level, calculate basal adjustment, and deliver insulin. See, that might be more detail in the real world, but this is just an example. And I use decomposition to show that there's a functional decomposition. And the only real difference here between the feature block and the function block is I'm saying, well, the feature block is at system boundary level, and I do have some relationships that I can do between the system block and the feature block to say that a feature is a system, for example, using generalization, that I don't allow with these function blocks. But I do allow function blocks to be decomposed to any level, as do I allow within the structural model here subsystems to be decomposed into any level, but not systems. So we're making a language choice within the profile to put meaning around these different types of block, but fundamentally it's a block definition diagram, and the notation is the same across both. So you would say in a conventional systems project, such as a Magic Grid with Cameo or Harmony with Rhapsody, we'd start with use cases, and I could do that. I'll show you an alternative, which is I've got an idea of a context diagram, where the context diagram is going to show me the relationships that the system has with external actors. So it's very similar to a use case diagram. This is an internal block diagram and it's got parts which are typed by actors. Obviously I haven't really got drivers using an insulin pump system. I've probably got a patient. So if I rename that actor as a patient, I could say that there's an interaction between the patient and the systems. The patient requests a bolus correction and the system delivers insulin. This simplified internal block diagram does have a very simplified palette, so we're using flows between part properties, and the flow is carrying signals, or what Rhapsody calls events, because that's one of the easiest things to hook into lots of different diagrams within SysML to be able to capture exchange items. But I could show within this insulin pump system a feature which is typed by, or a feature usage which is typed by that, and establish the flows to those features. If you think of this as similar to what a use case would do, the difference is instead of having an ellipse here and having a use case, I've got a block. To do this, I've only actually used two different types of diagrams so far. I've used block definition diagrams to do decomposition. I've used a high-level internal block diagram. When I say high-level, I mean an internal block diagram where the part properties are global. I've got the concept of a block called a feature, which is decomposable into functions, and I can then establish relationships between these blocks, and although I could do it with allocation dependencies, what this opens up quite easily is the ability to do allocation through composition. I could say, well, actually my calculation of basal adjustment is done by the insulin pump. My delivery of insulin is actually also done by the insulin pump. And my measuring of glucose levels is done by the continuous glucose sensor. If I wanted to, I could go into using internal block diagrams. I've got an internal block diagram here. I could populate the parts, and I've got a helper here to be able to do that. Some of these are function usages, some of them are subsystem usages. If I just say populate them all, you'll see how it dovetails the two together. Just compact this a bit because my screen size isn't so good. So my insulin pump then might have connections with the continuous glucose sensor. The helper's going to automatically create some interface blocks and conjugate one of the ports. If I do that, I could say that the measuring of the glucose level, so maybe it's on this way is a better way of doing it. I could say measuring glucose level produces flows on this connector into, move that around. So these are actually parts. So you see how I'm using part properties within a structured compartment here to be able to see both entities. So that will be a flow input into that function usage, which is part of the insulin pumps. This gives me some sort of unique but recognizable views, which I can't quite do as closely using activities as I can with parts and blocks. If I wanted to, and this might be a pre-step, I could take that feature and then take the part properties and chain them purely in a functional model. So I measure glucose level, and that flows. I haven't typed these by events, but I could. That flows to calculating the basal adjustment, and then calculating the basal adjustment flows into the delivery of insulin. And the helper here is creating some flow ports there. And if I wanted to, I could put some conditional logic or parallel logic, and I'm using business process notation here because that works quite well with nodes. But this is actually an internal block diagram being used to perform the function that a activity diagram would have. So it's relatively powerful notation, but I've got the whole port part capability in that this measure glucose level function block here, assuming that's essentially a capability and it owns things like a requirement diagram. So if I have requirements that the function block owns, then if I allocate this function block to a subsystem, then I'm essentially allocating the requirements. And these function blocks then become these reusable elements. So I could create a completely different architecture with different subsystems and allocate the same functions if I wanted to, or I could start to use some of the things of object orientation such as generalization and composition to assemble reusable functionality as a block and then reuse that functionality in another system. It's SysML, but all these diagrams I've done entirely with the notation of blocks, definition diagrams, and internal block diagrams. I haven't used any use cases, haven't used any activity diagrams, haven't used any sequence diagrams. But I can achieve quite a lot with a very small syntax. And once you understand that small syntax, you can express quite interesting relationships and start to assemble systems from reusable components. So it's a more fluid, dynamic way of using SysML, which does rely on some extensions here to be able to specialize the types of blocks, but is something that may be interesting if you're into this idea of functionally decomposing system capabilities rather than trying to say, well, we need to express our system in terms of a SysML sequence diagram or state chart. So I thought I'd show you that. It's a slightly different approach to SysML. There's lots of different ways you can use SysML, but I think the idea of only using two diagrams is actually quite clever. If you need any more information, then let me know.